Hello children, we already know that current is the rate of flow of charges. Now the charges will not be moving on its own. Some work will have to be done so that the charges are kept in motion. And so here we are going to talk about a new topic, which is potential difference. This is the next term which is associated with electric current and a very important terminology that you must understand. Before knowing about potential difference, it is necessary to understand what is electric potential. If you imagine an electric field as shown here, it may be due to some charge. Electric field is an area around a charge where its effect can be felt. So if we consider a point in this electric field A and we consider a unit positive charge which is kept at infinity, and if it has to be brought to this point A, then some amount of work has to be done. So this amount of work done in moving a unit positive charge from infinity to this point A is called as electric potential. Now let us look at this figure. Here I have drawn two tanks and there is water filled in both tanks, but to different level. Now you can understand from this figure that water will be flowing from tank A to B due to the difference that there is a level difference in tank A and B, which leads to a pressure difference in tank A and B. So water will flow from A to B due to the pressure difference. Similarly, you also know that when you talk about heat, it always will flow from a body which is at a higher temperature to a body which is at a lower temperature. So as water flows due to pressure difference and heat flows due to temperature difference, we can say that electrons move if there is a difference of electric pressure, and this electric pressure is basically called as potential difference. So for the movement of the charges, it is necessary that there is a potential difference provided across the conductor so that the charges can move. And now what provides the potential difference? Now if we consider a cell or a battery, there is a chemical reaction going on within the battery. This chemical reaction will generate a potential difference across the terminals, even if it is not giving out any current or there is no current drawn from the cell. So this chemical action will continuously generate a potential difference. So if now this cell is connected across a circuit, what it will do is that it will create this potential difference across the terminal, and this potential difference will be responsible for the charges to move through the circuit. So the cell or the battery's job is to provide the potential difference so that it can actually make the charges move. So we will now see that the current is maintained in a circuit when the cell keeps on expending its chemical energy. So as long as the cell keeps on expending its chemical energy, we will see that the current is going to be maintained. This is what is called as the electric potential difference. So the cell or the battery will be providing the potential difference so that the current is kept on moving or the charges are kept in motion. So what is an electric potential difference? So if you have a piece of conductor like this, and if the charges are supposed to move from one end to the other end, let us say A to B, then the potential difference across A and B is defined as the amount of work done to move a unit positive charge from A to B. So we can define electric potential difference across the ends of a conductor as the amount of work done to move a unit positive charge from one end to the other end. Or you can also say that electric potential difference across 2 points is defined as the amount of work done to move a unit positive charge from one point to the other. So we will write the potential difference is equal to work done upon charge. Here V indicates the potential difference, W indicates the work done, and Q is basically the charge. So depending on the definition, we have the formula V is equal to W upon Q. The SI unit of potential difference is volt, which is named after the Italian physicist Alessandro Volta, and volt is also given by the capital letter V. So both here you have to note down the difference, that potential difference as well as its unit both are given by V. So from this formula, V is equal to W upon Q. We write it with respect to their SI units. 1 volt is equal to 1 joule upon 1 coulomb. You know that joule is the SI unit of work done. We have a measuring instrument which is called as voltmeter, and this voltmeter is used to measure the potential difference, and it is always connected in parallel across the points where you have to measure the potential difference. So an ammeter is a measuring device which will measure the current, but a voltmeter is a measuring device which will measure the potential difference, and it will be always connected in parallel. Thank you.